Hello everyone, in this video we study about the unbalanced assignment problem, restricted assignment problems. But for understand this assignment problem, first you all know about the balanced assignment problems, and in which the minimization assignment problem and maximization assignment problems are all you know about that concept. If you don't know about the knowledge of maximization assignment problem and minimization assignment problem, then see the previous video. In that video I explain all these concepts detail. So now we move for the unbalanced assignment problem. So let's start. So unbalanced assignment problems means what? The number of rows are not equal to number of columns, or the number of columns are not equal to number of rows. Means assigned task is not equal to the facilities, or the facilities are not equal to the task. Let's suppose one matrix is J1, J2, J3, which are the jobs, and M1, M2, M3 and M4 are the machines. So for the J1 job we has 4 machines, for the J2 has the 4 machine, and for the job J3 has a 4 machine. The target is assign a job for the machines, so we get minimum or the maximum cost of the job. But we can see here for the 3 jobs we have 4 machines, so this is unbalanced because 3 row and 4 columns are present. So first steps to solve the unbalanced assignment problem is convert the unbalanced assignment problem into the balanced assignment problem, and for that add one dummy row or the column. So when we add a dummy row means all the values of the row or the column are the 0. So when the number of rows are the less than the column, then add the dummy row, and if the number of columns are the smaller than the number of rows, that time add the dummy column. So in this example we have 3 rows and 4 columns. So we add here one dummy row which is J4, and the values of the dummy row is 0, 0, 0. So now the matrix are the balanced matrix, which is 4 by 4. Now once we get the balanced matrix, then we know all the steps for the solve the problems for the minimization or the maximization of the assignment problems are the same. I hope you all get idea how we convert the unbalanced assignment problem into a balanced assignment problem. So let's suppose the question is a company has a 4 machine M1, M2, M3, M4 and the 3 jobs. Each be assigned to a one and only one machine. The cost of each job on each machine is given in the following table, means in that matrix. What are the job assigned which will give a minimization cost? Means here we find out the minimum cost for the job. So let's start to solve. So first step we already completed. We add one dummy row and converted into a balanced matrix. This is our first step. So now the second step is same. Find out the minimum value from the each row and subtract from the respective rows. So from the first row 18 is the smallest. So this is 0, 6, 10 and 14. Because 24 minus 18 is 6, then 28 minus 18 is 10, and 32 minus 18 is 14. Now we move for the second row. So 8 is the smallest. So here this is 0, 5, 9 and 10. From the third row, the 10 is the smallest. So 0, 5, 9 and 12. And for fourth row, the 0 is the smallest and all the values are the 0 itself. So this is now our reduced matrix. So second step also we completed. Now we move for the third step, which is find out now the minimum from the each column. But here one step is reduced by the dummy row, because if we see each column, the 0 is the smallest value, and any value subtract from the 0, the values are the same. Not any change is done by the all the values. So all the columns are the same for the column operation, because here is also minimum value from the first column is 0, from the second column also the minimum value is 0, from the third and fourth also the minimum value is 0. So all these values are the same for the column operation. Here we perform the row operations. These are the jobs, and these are the machines. So our reduced matrix for the column is same for the row operations. So this is our reduced matrix. Once we complete all row operations and the column operation, then we assign the assignment. So we know for the assignment, we check each row and each column any has a single 0 or not. If a single 0 is present from each row or the column, then we assign the 0 as an assignment. So in this example, the first row itself has a single 0, so we assign this 0 as an assignment. Now cross all the zeros from the respective rows and the columns of the assignment element. Cross all the zeros. In the row, no any single 0 is present for the cross, but in the column 3 zeros are present and we cross over there. Now we move for the second row, but in second row no single 0 is present. For in the third row is also no single 0 is present, but in last row the 3 zeros are present, but we not want 3 zeros, so we check for the column. Any column has a single 0, so as in the second column itself has a single 0, so we assign as an assignment and cross all the zeros with respect to rows and the columns. Cross these zeros, so these two zeros now cross, and in the column no any single 0 is present. Now we check any row or the column has a 0 is present, and if present then we give the assignment. But now the zeros are the completed, no any 0 is remain to assign or the cross. So the next step, we draw the lines for the assignment. So the steps are the simple. Tick the rows which has no any assignment. So for the second row we not assign any 0 as assignment. For the third row also we not assign any 0 as assignment, but the first and the last row has a 1 1 assignment, so we not tick there. So once we tick the rows, then find out the cross zeros. So here in the first column the cross 0 is present for the third row, and for the second row and for the third row the first column has a crossed 0, so tick there where the crossed 0 is present. So in the first column has a crossed 0, and from the crossed column, in ticked column, check any assignment of the 0 is present or not, and where the assignment 0 is present, tick with respect to that row. So I hope you get the idea. First we tick that row whose no any single assignment are the assigned. So here two rows are the rows which has no assignment, so we tick there. Then in the row check for the crossed 0 and tick for the respective column. So for the first column has a crossed 0 is present, so we tick that first column. Then in the column we check for the assignment 0. So assignment 0 is present in the first row, so we tick the first row as a assignment 0. So here 3 rows has a ticked and 1 column has a tick. Then draw the lines, but the lines are Draw for the unmarked row and marked column. I hope you know the objective to draw the line. By using that lines, we cover all these zeros. So unmarked row, these first three are the marked rows, but we want unmarked row, which is the last one, and the marked column, which is the first column. So we can observe here, so all the zeros are covered by the two lines, marked column and unmarked row. Now the next step, find out the smallest value from the unmarked values. So from the 655, 1099, 14, 10, 12, these are the unmarked elements which is not covered by the line. So find out the smallest value from the uncovered element, which is the 5, and subtract from the each element which are not covered by the lines. So subtract from the uncovered lines, smallest value, first subtract from the uncovered value, uncovered element. Second, add at the intersection point of the line. So here only one intersection formed by the two lines, which is at the 0. So add the smallest value, add it means the smallest value at the intersection point, and remaining all the zeros which are covered by the single line, write as it is. So third step, all the elements which are covered by the single line, write as it is. These three steps now we follow to write the further reduced matrix. First, find out the uncovered elements, and from the uncovered element find out the smallest value. Subtract smallest value from the uncovered element, add it at the intersection, and remaining all elements write as it is. So let's rewrite. So 6 minus 5 is 1, 10 minus 5 is 5, 14 minus 5 is 9. Here 1, 5 and 9. Now here 0, 4 and 5, because 9 minus 5 is 4 and 10 minus 5 is 5. So 0, 4, 5. Now 5 minus 5 is 0, 9 minus 5 and 12 minus 5. 0, 4, 7. So first step we complete. We subtract the smallest value from the uncovered element and write the elements. Now add the smallest value in the intersection point, means 0 plus 5 is 5. So this is our second step, because at this 0 two lines are the cross to each other, and this is our intersection point. So here is the 5. Now all the elements which are covered by a single line, write as it is, means these 3 zeros and these 3 zeros we write as it is, because these are the covered by a single line. So this is now our reduced matrix, and once we get the reduced matrix, now our target, again we assign the assignments. Now all the steps again as it is. First check any row has a single 0. Yes, here the first row itself has a single 0. Then we assign as an assignment, cross all these zeros with respect to row and column. Then we move for the second. Again we check any row has a single 0. Yes, second row has now a single 0 because this is now the cross, and we not consider cross 0. We only consider 0. So we cross again all these respective 0 as a cross. Now we move for the again next row. So in the third row, no any 0 now remain to assign, and in the last row 2 zeros are the present. But we first check any row or any column has a single 0 present or not. So now we check for the column. So first column one assignment is present. For the second column is also one assignment present, and no any 0 is remain to assign. But in the third column the 1 0 is present. So we cross that 0 and cross the respective zeros. So now no any single 0 is remain to assign, but we not get here optimal solution, because for the optimal solution we know each row and each column has at least one assignment. So now we again draw the lines. So for the how we draw the lines, we know tick for the that row which has no any assignment is present. So we tick for the third row. Now we check the crossed 0. So in the third column and the first column and the second column has a crossed 0. See carefully. First we tick for the row which has no any single assigned 0. Now we check with respect to that row where the single 0 is present, crossed 0 is present. So here at the first column and the second column has a crossed 0. So we tick for that two columns. Now the respective column check the assigned 0 is present or not. So first column has a assigned 0 present at the first row. So tick for that row, and for the second column the assignment 0 is present at the second row. So tick for that row. Now draw the lines, and the lines are drawn for the unmarked row, which is the last one. So this is our unmarked row and marked column. So marked column is first column and the second column. The objective is again with the help of the minimum lines we cover all the zeros. So we can see here we cover all the zeros in the 3 lines. Now again the further steps are the same. The uncovered element C, select the smallest element, subtract from the all these uncovered elements. So the 4 is the smallest element, so subtract 4 from the free element. So here 4 minus 1 is 5 minus 4 is 1, 9 minus 4 is 5, 4 minus 4 is 0, 5 minus 4 is 1, again 4 minus 4 is 0, and 7 minus 4 is 3. So first step we completed, subtract the uncovered smallest value from the uncovered element. Now the second step, add it at the intersection point. So 5 and 0 are the intersection point in the matrix. So add V first value in the 5 and 4. So 5 plus 4 9, 0 plus 4 is 4. Now the third step, all the elements covered by a single line write as it is. So all the elements which are covered by a single line write as it is. So this 0 0 and 0. Now the second column 1 0 0 and these 2 zeros write as it is because these are covered by a single line. So now this is further reduced the matrix. These are the jobs. these are the machines. M4. Once we get the reduced matrix, again we assign the assignment. So for the assignment, check any row has a single zero. If yes, then cross the zero as assignment. Then cross the zeros with respect to all the rows and the columns. Now we check for the further rows. Any row has a single zero. For the second row, 2 zeros are present. For the third row, 2 zeros are present, and for the last row, 2 zeros are present. Once check all the rows, now check the columns. Any column has a single zero. So for the second column, 2 zeros are present. For the third column, 3 zeros are present, and for the last column 1 zero is present. So assign that zero as an assignment. Then cross all the zeros with respect to rows and the column of the assignment element. Now again check rows and the columns, but in the row 2 zeros are present in the second and the third row, and for the column also, for the second and third column has 2 zeros. So here we start from any zero. Let's suppose we start from here. So cross all the respective zeros of the assignment element. Now here is the last zero, which are the single for the row and the column. So we can see here all the 4 rows and the 4 column has a 1 assignment. So once we get all row and for the column has a 1 assignment, then that time we say that here is the optimal solution. So schedule for the jobs are: for the J1 we assign machine 1, for the J2 job we assign the machine M3, for the job 3 we assign the machine M2, and for the job 4 we assign the value M4. Now we write here the cost. The cost is right from the original value, original matrix. So J1 and M1. So J1 and M1 has a 18 cost, and J2 and M3 has a 70. J3 and M2 is 15, and J4 and M4 has a 0. These are the cost. So we write here 18, 13, 19 and 0. These are the cost, and the value, the total cost is 15. So minimum cost of the machine is 50. Cost for the job of the machine is 50. I hope you all get idea now how we find out the values for the unbalanced assignment problem. Only small change: if the matrix is unbalanced, then add any row or the column, a dummy row and the column, and get it converted into a balanced matrix, and remaining all the steps are the same for the solve a minimum or the maximum assignment problem. We see one more example. So in this example we have 6 row and 5 columns. So now here we add a 1 dummy column to convert the unbalanced assignment problem into a balanced assignment problem. So when we add the dummy column, then we convert it into 6 by 6 matrix. So first steps we follow here. We add a dummy row. So the 6 to 5 to 6. So here we add 1 dummy column whose value is 0 for each row. So now we converted the matrix in 6 by 6. First the original matrix is 6 by 5 matrix. Now we add a 1 dummy column and converted into a balanced assignment problem, which is 6 by 6 matrix. Now all the steps for the solving the assignment problem is same as it is as the balanced assignment problem. If you want to find out the minimum value, then simply find out the row minimum from each row and subtract from the respective row, and then find out the maximum minimum value from the column and subtract respective column. And if you want to find out the maximum value, then that time find out the maximum value from the whole matrix, then subtract it from the each element of the matrix, and then we get the reduce the matrix, and then all the remaining steps are the same. Let's suppose in this example we find out the minimum value. So if we want to find out the minimum cost of the matrix, then simply find out the row minimum and subtract it from the respective rows. And then second step, find out the minimum column, minimum element from the respective columns and subtract it from each column. So here the one step is reduced because if we see carefully, then each row has a 0 is the minimum value, and if we subtract any value from the 0, then the value is not changed. So for the row operation we get the same as it is matrix we get. In previous example we add the dummy row. That time we not perform the column operation because each column has a 0 as a minimum value. But in this example we add a dummy column. So in that example we not change any row operation, we perform the column operation. So minimum value from the first column is 2. So 6 minus 2, 2 minus 2, 7 minus 2, 6 minus 2. So in this way we write all the first column, then the second column again 2 is the smallest. Same as it is, we subtract 2 from each element of the column. So in this way we write the reduced matrix. So this is our now reduced matrix. It is 6 by 6. We only perform the column operations, we not perform any row operation. Once we get the reduced matrix, then we assign the assignment. So for the assignment we check the rows if any row has a single 0. Then first row has a 3 0, second row has a 2 0, and third row has a single 0. So first we assign that row 0 as an assignment, then we cross all the zeros with respect to that assignment element. All the 0 get crossed, and now any row has a 0 present at the assignment element. So at the column we cross all the 0 as a crossed. Now we move for the next row. Any row has a single 0? No. Here the 3 0 are present. Here no any single 0 is present. Now we check for the column. Any column has a single 0 are present. So yes, in the first column we see the single 0 is present. So we assign as a assignment, then cross all the zeros with respect to row and the column has a 0, then we get crossed, but no any single 0 is present with respect to that 0. Now we move for the further next column, but in second column 2 0 are present. In the third column single 1 0 is present. So we assign as assignment, then cross all the 0 with respect to that row and the column. Now we move again. The third column is also single 0 is present, and cross all the respective zeros of the rows and the column. Now all the zeros are completed now, but we not get here optimal solution. No, each row and or each column get the assigned. So check which row has no get any assignment. So these last 2 rows not get the assignment. So as now we draw the lines to cover all the zeros. So we know the steps. Tick the rows which has no any single assignment. So these are the 2 lines. Then check any cross 0 is present at that respective rows. So in fifth row the crossed 0 present at the F column, and for the sixth row is also the crossed 0 present at the F column. So now the F column get ticked up. Now Now check at that respective column any assigned 0 is present or not. Yes, here at the third row the assignment 0 is present, then tick for that row. Once we completed that step, then we draw the line. Draw the lines for the unmarked rows, which is 4th row and first 2 rows. Unmarked rows and marked column. And after draw the lines, the objective is from that minimum lines we covered all these zeros. So we can see here we cover all the zeros from the respective lines. Now the next step, find out the smallest value from the uncovered element. Here the 5, 6, 3, 7, 7, 1, 5, 7, 2, 5, 1, 4 and this 2 and 3 are the uncovered elements which are not covered by the lines. Find out the minimum value from that element. So 1 is the minimum value from all these uncovered elements. So first step, subtract from the uncovered element. So we subtract. So when we subtract 1 from the uncovered element, we get here 5 minus 1 is 4, 6 minus 1 is 5, here is the 2, 6 and 3 minus 1 is 2. Only we now perform the operation for the uncovered element. Here 6, 0, 4, 6, 1, 4, 0, 3 and 2. So first step we completed. We subtract smallest value from the uncovered element. Now add the smallest value at the intersection point. So here the 3 intersection point, 1, 2 and the 3. So add the smallest value at the intersection point. So smallest value is 1. So 0 plus 1 is 1, 0 plus 1 is 1 and this is also 1. This is present at the fourth row, so here. Now remaining all the elements which are covered by a single line, write as it is. So 4, 0, 2, 0, 1, 0, 3, 5, 5, 2 and 4, 0, 0, 2, 0 and these are the zeros. These 0 are covered by a single line. We write all the elements which are covered by the single line as it is. Now this is our reduced matrix. And once we get the reduced matrix, again we move for the assignment. So we give the assignment for the each row and the column. So first check any row has single 0 is present. Here yes, in the second row this single 0 is present. So we assign as assignment. Then we cross all the zeros with respect to that assignment, but no any at the row at the column 0 is present. So we not cross any single 0. Now we move for the second. At the third row single 0 is present. So we assign as assignment. Cross all the zeros with respect to rows and the columns. Now for the fourth row 3 zeros are present. Fifth row 1 0 is present because 1 is get now crossed out. So fifth row is as assignment. Then cross all the zeros with respect to rows and the columns. Now for the sixth row the single 0 is present. So cross all the respective rows and the columns. Now we check for the next. Now here fourth row, as if we observe carefully, then we get the single 0. So check any 0 is present at respect to that column and row. No. Now we check for the first row, the single 0 is present and we assign as assignment. And if we see carefully, then each row has a 1 1 assignment and each column has also 1 1 assignment. So this is now our optimal solution. So now we write the minimum value from the original value. So here we assign 1 for the D, 2 for the A, 3 for the F, 4 for the E, 5 for the B and 6 for the C. So we write here the schedule for 1 D, 2 A, E, F, 4 E, 5 B and 6 C. Now we write the cost. So cost right from the original matrix, which is for the 1 and D, 2 is present, 2 and A, 3 and F, 3 and the F means our dummy column. So here is the suppose the dummy column and this is the value for the 3. So 4 and E, this is the 5 and B, 5 and B is 3 and 6 and C, this is the 4. Write all this value in our schedule. So minimum time is to perform the task is summation of all these values, which is 60. So I hope you all get idea how we convert the unbalanced assignment problem into a balanced assignment problem, and then we find out the minimum or the maximum value. Now we move for the restricted assignment problem. So the assignment problem with restrictions. In general assignment problem, there may be a restriction on the assignments of the job to the facility. In other words, the job cannot be assigned to a particular facility. This difficulty can be solved by assigning a very high cost, means infinity, to the corresponding element in the matrix, so that possibilities of the assignment of such restricted element will be automatically excluded from the optimal assignment schedule. So let's see how we overcome these restrictions. So for example, 4 operators 1, 2, 3, 4 are available to the manager, who has to get 4 machines A, B, C, D, done by the assigning 1 machine to each operator. Find out the optimal assignment so that the total cost will be minimum. But if we see the cost matrix, then at the C and in the D column, the cell 1 and C and 3 and D has no any value to assign. So this is the restriction. So to avoid this restriction, we assign a 1 value, which is infinity. So when we assign infinity, so no any change, because any value subtracted, added from the infinity, the answer is always infinity. So no any impact on the assignments, because for the assignment we know the 0 is comes in a picture, but when we write the infinity at the restriction, that time when we subtract any value from the infinity, then the answer comes infinity, and that value are not assigned by the assignment, because these values are taken by the infinity. So let's see how we solve the example. So the first step, write the infinity where the restrictions are the come. So here 1 and C has a restriction, we write their infinity, and the 3 and D has a restriction, we write there again infinity. Now the remaining all the process are the same. So in this example we want to find out the minimum value. So first step, we know find out the minimum from the each row and subtract from the respective rows. So in the first row, the 2 is the smallest. So here 3, 3, infinity, because infinity minus 2 means infinity, because we not know the particular value of the infinity. This is 10, 100, 1000, 2000, we don't know. So when we subtract or add any value in the infinity, that time the answer is also comes infinity, and here is the 0. Now from the second row, again 2 is the smallest. So 5, 2, 0, 1. From the third row, 2 is the smallest. So 7, 0, 3 and infinity, and again at the last row 2 is smallest. So 5, 0, 4 and 5. This is the second reduced matrix. Now the third step, find out now the minimum from the column and subtract from the respective column. So from the first column 3 is the smallest. So 0, 2, 4 and 2. Now from the second column 0 is the smallest. So the column write as it is, because any value subtract from 0 the value remains same. Here the third row, again the 0 is the smallest. So we write the column as it is, and from the last again 0 is the smallest. So write as it is. So these are our machines and these are the operators. So once we get the reduced matrix, then we assign the assignment. So first, when we assign the assignment, we check any row has a single 0, and if yes, then we assign as an assignment. So in the second row we can see this single 0 is present. Now cross all these 0 with respect to that assignment, cross off all the 0. So no any 0 is comes in the respective row and the column. So we move for the next row. In the third row again 1 0 is single, and this is the assignment. Now cross off all the 0 with respect to the assignment 0. Now we move for the next row. Any row has a single 0? No. Now we check for the column. Any column has a single 0? Yes. In the first column the 1 0 is present, single 0. So this is the assignment now. And now cross all these respective rows and the column 0, cross off. So this now 0 is crossed off. But here we not get the optimum solution. For the optimum solution we want each row and each column has a one assignment. But in the fourth row we not get the assignment. So we know when we not get the optimum solution, then we draw the lines. So how we draw the lines? First tick the row which has no assignment 0. Now check that row and tick for the column whose crossed 0 is present. So here in this second column the crossed 0 is present, so we tick for the respective column. Now in the respective column check where the assigned 0 is present and tick for the respective row. So here in the second column third row has a assigned 0. So tick for the third row. So here we tick all these rows and columns. Now we draw the lines. So we know how we draw the lines. Draw the lines from the unmarked rows. These are the unmarked rows, and marked column, which is the second column. So at the 3 lines we cover all the zeros of the cost matrix. Now further procedure again same as it is. Choose the smallest element from the uncovered element, which is 2. Subtract smallest element means 2 from the all these uncovered element. Add 2 in the intersection point of the lines, and remaining all the elements write as it is. So let's write the reduced matrix now. Let me write here for the simple understanding. So 2 is the smallest. First we subtract from the unmarked elements. So 4 minus 2 is 2. 2 minus 2 is 0. Now 3 minus 2 is 1. 4 minus 2 is 2. Infinity minus 2 is infinity. And 5 minus 2 is 3. Now add at the intersection point. So 3 plus 2 is 5, because here is the intersection of two lines. So 5. 2 plus 2 is 4. Now remaining all these elements which are covered up by the single line, write as it is. So this 0, 2, this infinity 0, infinity 0 and 0, 1. So this is our now reduced matrix. Now once we get the reduced matrix, then again we assign the assignment. For the assignment, check any row has a single 0. Here the second row has a single 0. We assign as assignment, then cross off all the zeros with respect to that column and row. Now we move for this next step. We again check any row has a single 0. So here at the third row we see this single 0 is present. Now cross off the zeros with respect to rows and column. So at the column 1 0 is present, but in the row no any 0 is present. Now we move for the next. So here now in the fourth row single 0 is present. We not consider the crossed 0. We only want the single 0. This is the assigned 0. Now cross off all these respect to rows and columns. Now we move for the first row, because now only single 0 is present in the first row. And if we see carefully, then each row and each column now has a 1 1 assignment. So here is the optimum solution of the assignment problem. So these are the operator 1, 2, 3 and 4, and these are the machine and D. So our schedule is for the operator 1 machine D, for the operator 2 machine C, for the operator 3 machine is D, we can see here, and for the operator 4 machine A is assigned. Now the cost we refer from the original value. So 1 and D has a original value 2. So we write here the cost, which is 2. Now 2 and C, 3 and B. So 2 and C is 2, 3 and B is 2, and 4 and A is 7. So we write all this cost in our schedule. 2, 2 and 7. So the minimum cost is now cost is equal to 30. The summation of the all the cost. So I hope all you get idea how we solve the assignment when the restriction is come. One more example. So in this example we see the cost matrix is, first is the restricted matrix, means the problem is restricted assignment problem, and second one is this is the unbalanced assignment problem, because the machines are the 4 and the operators are the 5. So first we convert the given problem into a balanced assignment problem, and side by side we write the infinity where the restrictions is the count. So first A, B, C, D, E. Now here we want to add one dummy row, because the column has a 5 and row are the 4. So we write one extra row which is dummy row. So this is M1, M2, M3, M4, and now this is the M5, which is the dummy row. So value of the dummy row is 0, 0, 0. Here is the infinity. Again here is the restriction, so we write here infinity. Our original cost matrix. Now the remaining all these steps are the same. We want to find out the minimum cost. So we know first find out the smallest value from each row and subtract from the respective rows. So we quickly perform here. from the first row, the 9 is the smallest. So from the second row, again 9 is the smallest. Here infinity minus 9 is infinity, 1 and 0. Now from the third row, the 11 is the smallest. So infinity minus 11 is infinity. Where is the 0, 3? Sorry, here 7 is the smallest. So infinity minus 7 is the infinity. 11 minus 7. 11 minus 7 is 4, not 0. This is the 4. Now 14 minus 7 is 7. Here is again 4 and this is the 0. Now from the last row, fourth row, the smallest value is 7. So again here 7, 1, 5, 0 and 1. And from the last row, 0 is the smallest and all values are the 0. So this is now reduced the matrix. Now once we find out the minimum from the each row, now we find out the minimum from the column. But if we can see here, so we add here one dummy row whose value all are the 0. So from each column now 1 0 is added. So minimum value of each column now 0. So no any change occur in the cost matrix. So this matrix is now our final reduced the matrix. We not here perform the column operation. So once we get the reduced matrix, then we assign the assignment, and we know that how we assign the assignment. First, select the row who has a single 0. So in the first row, the single 0 is present. Cross off all the respective zeros from the row and column. Now check for the remaining row. Any row has a single 0. If yes, then assign as a assignment. So in the third row, 1 0 is present. So we assign as assignment, and respect to all the zeros from the row and the column, cross off. Now we move for the next row. So in the fourth row, again 1 0 is present. We cross off all the 0 with respect to that assignment. Now we check for the remaining rows. So if we see carefully, then in the second row we can see here single 0 is present, because now the second 0 is crossed off by the third assignment. So this is now single 0. Cross off all the respective zeros from the rows and column of the assignment. Now the last assignment is at the fifth row. So if we see carefully, then each row and each column now has a 1 1 assignment. So this is our optimum solution. So we write here schedule. For the 1 we assign A, for the 2 we assign B, for the 2 we assign B, for the 3 we assign E, for the 4 we assign D, and for the 5 we assign C. And now we write the cost from the cost matrix. So 99770, these are the values or the cost of the assignment. So minimum cost is summation of all these values, which is 32. So I hope all you get idea how we solve the examples of the restriction assignment problem, balanced, unbalanced assignment problem, and all. Thank you.